Hey there, what's up? It's Luke, and today I'm going to be talking about VLANs and inter-VLAN routing. So a VLAN stands for Virtual Local Area Network. Basically, what it means is that we're artificially dividing a network into different local networks, or we can combine two separate networks into one local network. We also have the ability and as you can see from this example, normally all four of these PCs or end clients are connected to this switch, so they would be considered part of a single network. But in this case, we want to set it up so that they're actually acting like two different networks: VLAN 10 on the left here and VLAN 20 on the right. So there are two ways to configure VLANs and inter-VLAN routing, and this stems from the fact that inter-VLAN routing is a process that requires both layer 2 switching capabilities as well as layer 3 routing capabilities. So the two methods are: first is router on a stick, which I have right here, and second, switch virtual interfaces, or SVIs, which I'm going to talk about later. But first, let's talk about router on a stick. Router on a stick is used in the case where we have a layer 2 switch. Layer 2 switch basically means that this switch does not have routing capabilities. Therefore, it needs a router on top, or quote unquote on a stick, to help with or handle the routing part of the inter-VLAN connection. What this means is that if you're ever trying to, if we have the, once we have the setup, if we're ever trying to send a packet from VLAN 10 to VLAN 20, it can't just go through the switch. What it has to do is it has to go to the router and back to the switch and then to the separate VLAN. And we'll see that in action in just a little bit. Okay, so let's start by looking at our network here. And there's a few things I want to point out, which is that because we're treating VLAN 10 and VLAN 20 as separate networks, right? They're going to have their own unique network properties. That includes stuff like they're going to have different IP network addresses, and they're also going to have different gateways. Normally, if these were all part of one network, you would have one default gateway, which would just be the IP address for this interface here on this router. But that's not going to be true in this case because we're going to be treating them like two different routers. So, sorry, not two different routers, two different networks. So the first thing we need to do is go ahead and configure all of the IP addresses and networks on this on these end clients, on these hosts. So we can go here, IP configuration, and set the IP addresses here. For PC0, 192.168.10.2 here is going to be IP address. Packet tracer automatically fills the subnet mask, but we can double check and it is correct. It is /24. And then we have to set the default gateway as well. That's very important, which is 192.168.10.1 because it's part of VLAN 10. For PC2, this client is part of VLAN 20. So the IP address is going to be 192.168.20.2. The mask is correct, and the default gateway will be 192.168.20.1 instead of dot. Okay. Now I'm going to jump and configure the IP addresses on these two as well. Okay, so I'm back and I've configured the IP addresses on PC1 and PC3. So let's start setting up the actual VLANs now. And let's go into switch 0, go to enable, and get into configuration terminal. Okay, so the first thing we need to do is obviously create the VLAN. So we'll do that with the command VLAN 10. And here, if you want to, you can name the VLAN whatever you want to name it, but it's not necessary. And we're going to exit and go to VLAN 20. So now we've created these two VLANs. Now we also need to add the interfaces that are relevant to these VLANs to the VLAN, right? For example, the fast Ethernet 02 and 03 interfaces are going to be part of VLAN 10, whereas the 04 and 05 interfaces are going to be 20. So let's start by going into interface FA02, which is this one right here. So now there's a few things we need to do. First thing, we need to set the switch port mode. Now there's only two modes, right? First one is going to be access mode, which is the mode that we use for an interface that's connected to a end host that only has one VLAN in it. The other mode is going to be trunk mode, which is a interface that has multiple VLANs, multiple VLAN traffic going through it. So in this case, FA2, 3, 4, and 5 are all going to be access ports, whereas only FA01, because it's connected to the router, so all the VLAN traffic is going to be going through here, is going to be a trunk port. So let's configure that on FA02. So switch port mode, and then access, and then we're going to add this interface to VLAN 10. So it's switch port access, and 10. That's our command. Now let's do the same thing for interface FA03. FA03. Port access and switch port access. I misspelled access. There we go. And obviously, we're going to do the same things for VLAN 20, but what you can do is use the interface range command, which is like this: interface FA02, FA02. No, we're not starting with 2. We're starting with FA4, and then do a dash to whatever interface you want. In this case, it's going to be 5, but you can go to, if I typed in 10 here, this would give you this will allow you to modify every interface from 4 to 10 at the same time. But we're just going to do 5. Oops. Oh. FA range 045. There we go. Sorry, I forgot the range keyword. You need the range keywords. Interface range, and then your dash. Okay. So switch port mode access, and then now switch port access, and both of these are going to be for VLAN 20. Now, if we exit and we do show VLAN brief, we can see what we've just done. We've created VLAN 10 and VLAN 20, and we've added ports 2 and 3 to VLAN 10, and ports 4 and 5 to VLAN 20, which looks good. Looks like about what we want to do. So now we're going to go ahead and have to configure this port right here, which is the trunk port. So int FA01, and instead of switch port mode access, we're going to do switch port mode trunk here. And now this port, this interface is now, this switch port is now in trunk mode. Now, because the trunk mode can have multiple allowed VLANs as opposed to the access port, which can only have one, the command we're going to be using to add VLAN 10 and VLAN 20 is going to be a little. So switch port trunk allowed VLAN 10, 20 with the comma, and make sure there's no space here. So now go to exit and show interface trunk. Oh, it hasn't updated yet, but it should update a little bit. We should be fine here. So this is good, and now let's go to the first thing we need to do is realize that we have this connection on G000 shutdown. So int G000 shutdown. And start at this. Now we're going to exit, and we are not going to actually apply anything to G000. What we're going to do is we're going to create a sub interface. So int G000, and then we're going to add dot 10. Now this is going to be the sub interface for VLAN 10. If I enter, it's going to create a new line here, and we're going to, you see, we've successfully gone into sub interface mode as opposed to interface mode up here. And now there's going to be two things we need to do here. First of all, we need to add this code, add this command, which is encapsulation dot 1q. Oh, and then we have to add the VLAN number here. So this is referring to the tagging mode for IEEE 802.1q. So that's where this .1q. And then next we're going to have to add an IP address, and the IP address we're going to use is going to be the VLAN 10 gateway address here. So IP address 92.168.20.10.1, and we get the subnet mask 255.255.255. There we go. Now we're going to exit, and we're going to do the same thing for the VLAN 20. We're going to make a new sub interface, int G000.20. Apply encapsulation .1q 20, and then add our IP address 192.168.20.1.255.255.255. There we go. And now we should all be set up. Let's go back to this and see if, there we go. Now the show interface trunk, and shows us that this FA01 port is a trunk port, and it's allowing our VLANs 10 and 20 through, traffic from VLANs 10 and 20 through. Okay, so now that should be it, and we should be able to ping. Should be able to ping from anywhere in VLAN 10 to VLAN 20. So ping 192.168.20. And as you can see, we're successful. The first request timed out, probably because of ARP, probably because we need to wait for ARP replies. But as you can see, we are successful. Now, there's also something I want to show you, which is the path that these packets take. If I do this ping again in simulation mode, when we step through the packet originates from PC1 is going to PC2. Instead of going directly to PC2, it first has to go to the router because it's InterVLAN traffic. The router sends it back to the switch, and then it goes back. And on the way back, it also does the same thing. It has to go to the router again, like so. And if I were to ping within the same VLAN, I'll turn on simulation mode again, and I got 168.10.2, which is this PC right here in the same VLAN. It goes from the PC to the switch and directly to this PC here and back. And there's no need for it to go to the router because it's all in the same network. It's all in the same VLAN. All right, so that's how to set up router on a stick. How to set up VLANs and InterVLAN routing using router on a stick. I'll be back in just a bit to show you how to do it with layer 3 switches and switch virtual interfaces. Hey there, I'm back, and I'm back with the other example, which is SVI, or switch virtual interfaces. And as you can see, the network here is almost identical. It's just that we swapped out this layer 2 switch here and this router on top for a layer 3 switch. So this layer 3 switch is going to do the job of both the router and the layer 2 switch combined. Other than that, the network is pretty much exactly identical. Same addresses, same gateways, and same VLANs. So I've already configured the IP addresses and gateways for all of the PCs here. It's the exact same as last time. So let's just get to configuring this switch. So, and the first thing we need to do is the same, is create the VLANs, right? So VLAN 10, name it if you want, and VLAN 20. That's it. Then the second step is still going to be the exact same. We're going to turn all these ports, FA1, 2, 3, and 4, into access ports, and we're going to set their VLAN to the correct VLAN. So first, int range. We're going to use the int range command to make this a little easier. And let's first do all the VLAN 10 ports, which is going to be FA0 and FA01 and FA02. So int range FA01 to 2. There we go. Now we can apply the commands to both. So switch port access, and then switch port access VLAN, and these are part of VLAN 10, so VLAN 10. There you go. That's it. And now we do the same thing for these two ports and on VLAN 20. Int range 0, 3 to 4, switch port access, switch access VLAN 20. So if we go to do show VLAN, see, we correctly configured this. All right. So now the first thing, now instead of configuring the sub interfaces on the router as we did last time, we're going to configure a switched virtual interface. And it's really easy to do. All you need to do is type in interface VLAN, and then followed by your VLAN number. Let's say interface VLAN 10. Now this is the layer 3 switch equivalent of the sub interface. You can think of it that way. So now we just add in the address for the gateway here. IP address 2.168.2.1, 55.255.0. And we can just exit and create another switch virtual interface for VLAN 20 and assign the correct IP address to that too. 168.20.1. And now that's all we need to do for the interface VLAN commands. It's a lot simpler. You don't have to type in the encapsulation.1q because you don't need to do that unless you're doing router on a stick. Now, before we finish, there's one very, very, very important step that you cannot forget. It's this command, IP routing. And what this command does, it enables layer 3 capabilities for your switch. So even though we have a layer 3 switch here, if we don't type in this command, it's going to act like a layer 2 switch. So, and in order to disable all the layer 3 capabilities, we could type in no IP routing too. Okay, so that's all. Now let's go to command prompt and try and ping from PC1 to PC2. So 168.20.2. And there we go. First one timed out again, probably because of the ARP requests and replies, but we are able to reach. So that is how to do inter-VLAN routing on switch virtual interfaces using layer 3 switches.